All right, so hey guys, we can also use the elimination method to solve systems and do it with subtraction. So I'm going to show you how that might work. All right, so if you take a look at these two systems of equations, you might think, hey, look at those y's. They might eliminate kind of nice. I have a 6y and a 6y. But if you combine those two equations, if you added them together, you would get 8x plus 12y equals 36. That's not going to help you. None of the variables would eliminate. So there are two different things that you could do. So instead of adding the two equations together, you can actually subtract them. Now remember, if you have a balance or a weight, as long as you're doing the same thing to both sides, it's okay. So I'm really going to subtract 6 from both sides. Because remember, this is like a 6 here. I'm subtracting 6 from that side, and then this also equals 6. So I'm really just subtracting 6 from both sides. Okay, so if I do that, you have to remember that you're subtracting. So I have to think like 3 minus 5. Well, that would be a negative 2x. And then 6 minus 6, well, the y's would be gone. So equals, and then 30 minus 6 is 24. All right, and then I could divide by negative 2 here, and I end up with x equals negative 12. Once you have your x-coordinate, you can go back and find your y-coordinate, just like we did before. But again, I just solved this using subtraction, so I was subtracting the same thing from both sides. Now, I want to show you one other way that I like to actually think of it a little bit better. Okay, so instead of adding or subtracting, or instead of subtracting this equation from both sides, I could actually times this whole equation by negative 1. Now remember, as long as you do the same thing to both sides, it's okay. So if I times that whole equation, I'm just working with that bottom one, it would be negative 5x plus negative 6y equals negative 6. Now, it's set up nice to combine the two equations or add the two equations to eliminate the variables. Now, I definitely don't screw up my signs. So 3 plus negative 5 is negative 2x. The 6's would cancel, and I would end up with 24 here, and I would solve it the same way. All right, so if you look at this next one, okay, obviously this is set up nice so that the y's would eliminate. You guys can see that here. Now, to get those y's to eliminate, one needs to be positive, one needs to be negative. So what I am going to do is I like to, instead of subtracting, because here's why, if you subtract, let me just show you. It gets a little confusing because now this says negative 2 minus 7. Sometimes that's hard to do in your head, negative 2 minus 7. You could add the opposite, you get negative 9s. So you can definitely subtract. I like to just times it by negative 1 instead, one of the equations. So I like to times everything by negative 1 and rewrite it. Then I get negative 7x and negative 3y and negative 21. Okay, so I just basically rewrote that one. Okay, now I can put a plus, I can combine these. Okay, and let's see what happens. So if I add my negative 2x and my negative 7x, that's negative 9x. The y's eliminate, because I have positive 3y, negative 3y. And then 48 take away 21 would be 27, positive. And then last step, divide by negative 9. And I end up with x equals negative 3. Okay, once you have your x-coordinate, you can go ahead and plug it in one of your two original equations to solve for your y. All right, so lastly, if you just kind of look at these, you always want to just kind of see what they're set up for. So if I take a look at this first one, I see 2 a's, which is nice, so I can eliminate them. So this one, you would either need to subtract these two, or you would need to multiply one of the equations by negative 1. Okay, now the second one, if you look at the second equation, I have a negative 2p and a positive 2p. That's set up nice already, because they'll kind of eliminate each other. So I can add the two systems together, and those will eliminate.